morning class. This morning I'll be taking you circle geometry, and we'll be looking at the subtopic chords, properties of circles. Now, for the learning objectives, at the end of the lesson, you should be able to recall and define the following: chords, arcs, segments, and other parts of a circle, and also apply the theorem, midpoint properties of a chord, and lastly, to use the theorem, equal chords, properties of a circle. Now let's take the definitions of these important parts of the circle. Now for circumference, the distance round the circle is called the circumference. Now this is called the circumference. And this is called a chord. A chord is just a straight line that joins two parts on the circumference. And this is called the radius, the distance from the center of the circle to any part or any point on the circumference. And we also have this line which we call the diameter. Now the diameter is a line that divides the circle into two equal halves. Then lastly, on the circumference, any 2 points on the circumference, the distance between any 2 points on the circumference is what we call the arc. So these are major parts of the circle that you need to know. Now, the first theorem that we'll be looking at, theorem 1. A straight line drawn from the center of a circle. This is the center of the circle, O. The straight line coming from the center of the circle to the midpoint of a chord. Now, the length AB is what we call a chord, which is not the diameter. It's at right angle to the chord. That is, this line coming from the center to this point forms angle 90 degrees. Now, don't forget that the length OA is the same thing as OB, radii or radius of the circle. Then AN is equal to NB. So the line coming from here to this place gives us what? 90 degrees. Now theorem number 2. A straight line drawn from the center of a circle is perpendicular to a chord and bisects the chord. Now bisects the chord simply means it divides into two equal parts or halves. This line coming from this place divides this chord into two equal parts. So the angle formed there is what we call 90 degrees. So that will make this length, the length AN is the same thing as the length NB or BN. So that's the second theorem we are going to be considering. Now don't forget that for these two theorems, you can apply Pythagoras theorem, and at the same time, you can also apply the trig ratio. Then lastly, the theorem we will be considering. Now, equal chords of a circle are equidistant from the center of the circle. Now, if chord, what this says is that chord AB from here to here is the same thing as chord CD. Now, if these two chords are the same, that means that the distance from the center of the circle to the chord, to the center of the chord, from O to N and O to M, that implies that ON is equal to ON, as long as the two chords are what? Are the same. So that will make our ON and OM to be the same. So that means that the distance between ON and OM, they are what? They are equal. Now don't forget that the line coming from here is the radius, which forms what? 90 degrees. 90 degrees. Now in solving these questions, don't forget we are going to be making use of this, the trigonometrical ratio, and also we'll use what? Pythagoras theorem, as the case may be. So with this, we are going to take more examples in the Google Classroom to apply these following theorems. With this, I'll tell you to meet me in the Google Classroom, so by then we can have more questions to solve. Thank you and have a nice day.